So when you are solving trig equations, the first thing you should ask yourself is, do I have like terms?
Wait, do we write on this?
What?
Do we write on this?
Yes. Are all of my trig terms alike?
Yes.
So on number one, are all of my trig terms alike?
Yes.
So step number one that I just had you write down says if you have like terms, you want to combine them and solve for that trig function. So I need to put my cotangents together. So I'm going to subtract the cotangent on the right to the left, which makes 2 cotangent. I'm going to subtract the 4 on the left to the right, which makes 2. So I have 2 cotangent equals 2.
Got that right.
I got that.
Divide by 2, I get cotangent equals 1. So cotangent equals 1 is the same thing as tangent equaling 1. So here's tangent, tangent, tangent equals 1 at pi over 4. And this number is a positive 1, so I have to figure out what 2 quadrants is tangent, or cotangent and tangent positive. 1 and 3, because remember tangent and cotangent are the combination of the signs. So that means my signs have to be the same in order to be positive, which happens in quadrant 1 and quadrant 3. So quadrant 3, the angle would be 5 pi over 4. So pi over 4 plus 2 pi n and 5 pi over 4 plus 2 pi n. Okay? So that falls under number 1. Okay, we put the like terms together and solve for the trig function. Next one. So 4 cosine squared plus 2 equals 3. So what's the first thing we ask ourselves? Of the trig functions given, do I have like terms? In this case, the answer is yes, because I only have 1 trig function. So if I have like terms, that tells me to do what?
Combine.
Combine my terms.
Right, but if I have like terms, what do I do? In this case, I've only got 1 term. Solve. I want to solve. So what do I do to solve this? Subtract 2.
Divide by 4.
Divide by 4.
Square root.
And take the square root. Okay, people usually do one of 2 things there. They forget the plus or minus, or they have issues taking the square root of 1/4.
I like that sign. That's why I got it.
I got the same.
So, I'm looking for a match of cosine and 1/2. Cosine and 1/2. The match happens at pi over 3. Since I have the plus or minus, what does that tell me?
They have 4 solutions.
4 solutions. So pi over 3 plus 2 pi n. Okay. Number 2, when I was grading the other 2 classes, number 2 was probably the problem we did the best on out of the 8.
Hey, I got number 1 right.
1 and number 2. 1 and number 2 are the ones
So
we
did I.
mostly got right. After that, then you never know.
Oh, I missed 1, but that's okay. It was close enough. Wait, don't turn it off.
What's up?
Is that a 3? 5 pi over 3.
5 pi over 3.
I need to work on that. Okay.
Alright, number 3. So again, first thing I ask myself is, do I have like terms? No. Like terms means I have the same trig function and it is the same power. That's what we mean by like terms. In this case, I have the same trig function, but I do not have the same power, so that means I do not have like terms. So that means I need to go to step 2. Step 2 says what?
Get them on one side and try to factor.
Get them on the same side and try to factor. So square root of 3, tangent squared x minus tangent equals 0. Say what?
Factor out tangent.
Yes. Okay, get them on the same side, and then we need to factor. The first thing you should always try to do when factoring is factor something out. So in this case, we can factor out. Now, some people are having issues figuring out what is left after I factor something out.
You said
It's just the same problem.
I'm talking about figuring out what this is.
Oh,
Square root of 10 is minus 1.
Square root of 3, tangent of x,
minus 1.
minus 1. The easiest thing is, whatever I'm factoring out, go back in and divide each of them by. So if I divide, that means that and that cancels. I'm left with square root of 3 tangent, which is what I have here. If I divide here, tangent divided by tangent, those cancel out, leaves me with 1. So if you're having issues with that, that's what you need to do. Okay, and then as Austin said, as soon as we factor, we should always set it equal to 0. So, and I should have hopefully banged into your head enough, anytime you see tangent or cotangent equaling 0, what should you do?
Add 1.
You need to think about it in terms of sine over cosine or cosine over sine. So since it's tangent, it's sine over cosine, so which one of these two has to be 0 in order for tangent to be 0? Sine. So that means I'm looking for a y value of 0 on the ordered pairs. Y value of 0 is there, y value of 0 is there. So that produces 0 plus 2 pi n and pi plus 2 pi n.
I got the 0 part, right?
So I need to finish solving the other one. So I'm going to add by 1 and divide by the radical. So I get tangent equals 1 over radical 3. So I look for a match. That match happens at pi over 6. Alright, that is a positive 1 over radical 3. So I'm interested in when both signs are the same, since I'm dealing with tangent. Both signs are the same in quadrant 1 and quadrant 3. So quadrant 3 would end up being 7 pi over 6.
Yeah, dude. I know.
Now,
I didn't do this.
I had several people, because they saw a square root, automatically put a plus or minus in there, which is incorrect. You only put the plus or minus in there when you do what? When you take the square root. If the square root's already there, you go with what sign is there. If you put the square root into the problem, that's when you need the plus or minus. Because there was some confusion when I was grading on that. People were putting plus or minus when they didn't need to.
Okay.
Question on that one? So far, the first one we put like terms together. Second one was the same thing. The third one was we got them on the same side and we factored. So, obviously, as we move down this list, the difficulty level of the problem increases. So far, we've done 2 of level 1. We've done 1 of level 2. Moving on to the third one. 3 cosine plus 3 equals sine squared. So what's the first thing we should be thinking? Do I have like terms? Answer is no. Then what? Get them on the same side. Which side do I want to go to and why? I would say the right. I always want my square term to be positive. Here's why. If I move it to the left and I replace it, what's going to be a common mistake that we make when we replace sine squared?
We put in the positive.
Forget to distribute the negative through. Because if I move the sine squared over here, I've got to replace sine squared with 1 minus cosine squared, and a lot of us are just going to put the minus on the 1 instead of making sure the minus goes there as
Is it
well.
okay to change it to the Pythagorean before you transfer it?
You can do that. You can do that as well.
That makes it easier. That's what makes it easier.
Yeah,
Yeah. That makes it
that's
easier.
what I did.
That's what I think, so I don't ever get that.
Okay. So I'm going to recommend you still move everything over before you replace.
So you want to keep the squared term?
I want the squared term to be positive.
Alright, cool.
Because the square term is the one I'm going to replace, and if it's positive when I replace it, I'm better off. So now I can replace it with 1 minus cosine squared. So 0 equals 1 minus cosine squared minus 3 cosine minus 3. Now what?
What?
What'd you say?
I was just saying this way you have a ton of negatives. I don't like it.
So we are now at the point where we're dealing with number 3. We've got multiple trig functions and we were not able to factor, so we made a Pythagorean substitution. So now I want to combine my like terms and factor. Make sure you put them in the correct order. So negative cosine squared x minus 3 cosine x and minus 2. Okay, so now our squared term is negative. We don't want it to be negative, so we want to change all the signs. So now we're ready to factor.
Wood.
Cosine x plus 2.
Divide it or multiply everything by
Plus
negative
1.
1.
Could you not just move over to the
I can move to the other side if I want to.
So I did that on one of these back problems. I just moved it all to the other side of the problem.
That's fine.
That's exactly what this whole thing.
Alright, so what type of factoring might I have to do here?
Trinomial?
I have a trinomial which factors into 2 binomials. So factors of cosine squared are cosine and cosine. Factors of 2 are 2 and 1. That sign tells me
Both sides the same.
the same, and that tells me
Bigger.
they're both positive. We always do immediately after we factor. Set them equal to 0. So the first one I get cosine x equals negative 2. We should automatically do what to that?
Cross it out.
Cross it out. Why do I cross that one out?
It's a negative solution.
Then you
Sine
can't
and
use
cosine.
a
Sine and cosine can only equal numbers between negative 1 and 1. Negative 2 is not between negative 1 and 1, so therefore it will not produce a solution. The other one I get cosine. Cosine equals negative 1. So I look, here's cosine, 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 no match there, so that means it's got to come from an ordered pair. Cosine is x, so I'm looking for an x value of negative 1, which occurs here, and the angle is pi.
Oh my god, I put that one right.
So I get x equals pi plus 2 pi
That's
n.
2, I've got mine.
I got it right, but I did it like completely different.
So did
Me
I
too.
did sliding
I'm
down
gonna take a nap.
first.
also equal.
Yeah, right, but you did it wrong.
Ow. Ow.
I did number 3. And he did, but I got the right answer.
Did you?
I did, but I marked.
I did number 4. I got
Did you
one
get
already.
Already substitutions incorrect.
I goofed and got the other half.
Cosine squared minus 1.
I got all of it. I said I had a spare,
I
so
got
that I
one.
took out the second. Okay.
Half of 2.
Alright, so far we've done 2 type 1, 1 type 2, and 1 type 3. So let's move to the back.
Actually, I got all of them.
Oh, here's the fun part.
Alright, so number 5. First thing we ask ourselves.
Yeah,
Like
same.
terms.
Do I have like terms? The answer is
No.
no. So what do?
Yeah.
Same side and factor. So I want to go to the left because that's where my squared term is. And it is positive. So the fact it's a trinomial, so we factor into binomials. The factors of sine squared are sine and sine. Factors of 2 are 2 and 1. That tells me different signs. That tells me larger one is negative. How can you always tell? What can you always do to tell if you factored correctly?
Plug it back in.
Multiply it.
Multiply it out. If you multiply it out, you should always get what you started with. So you should never get a factoring problem wrong. Or if you do, then you should know it's wrong before I agree. So set them equal to 0. Sine of theta equals, going to end up equaling 2, which is no good to me. Sine of theta equals -1. So it's not pi over 6, it's not pi over 3, it's not pi over 4. So I'm looking for a y value of -1, which occurs at 3 pi over 2. So we get 3 pi over 2 on that. So which level problem does that fall under?
2.
2.
Level 2. Factor.
Alright, number 6. 2 cosecant cosine equals 2 radical 2 cosine. Look for like terms. Do I have like terms? No.
Put it all on one side.
Put it all on one side. Does it matter which side I go to? No. Why not?
You don't have a
There's
square.
I don't have a square. Let's move it to the left.
Then back here, it's like what?
Okay? Once it's on the same side, we need to try to factor. We always want to see if there's something we can take out first.
2 cosine.
So we can take out 2 cosine.
Like midnight?
The same as all the other triple. See, I didn't know how that worked.
I didn't either.
It was
Hey, I
two
don't know.
at the radical, and I was like, yeah, I don't want to do
Yeah,
that. I know, imagine the radical just like that's one of the triple itself or an
Is it
exponent.
bad
I
for
did,
you?
and I even wrote that, but I was like, I don't know.
Well, here's what you can do. Anytime you see a trig function, replace it with a variable. So let's replace cosecant with x and cosine with y. So what would I factor out of that? 2 and y. So the 2 is the 2 and the y is the cosine. So I would factor out 2 cosine. So if you have trouble seeing it with trig, then replace the trig with variable.
I did this one really wrong.
So if I take that out, what's left?
Cosecant x minus
Cosecant x minus the square root of 2 is correct.
Then you set it equals 0.
Set them both equal to 0. So 2 cosine x equals 0, which means cosine x equals 0. The other one is cosine x equals radical 2, which means I'm interested in sine of x equaling 1 over radical 2. So cosine is not 0 at pi over 6, pi over 3, or pi over 4. So I'm looking for an x value of 0, which occurs at pi over 2 and pi over 3, or 3 pi over 2.
So close.
Yeah.
Sine equals 1 over radical 2. That occurs at pi over 4. And sine is positive. Sine goes with the y value. Y values are positive in quadrant 1 and quadrant 2. So quadrant 2 would be 3 pi over 4. So is that a level 1, 2, 3, or 4?
It's a level 10 on my scale.
3.
Oh my god.
3?
And is it level 2?
Oh, I don't know.
Do you know
Yeah.
the tornado is
It's
supposed
not a level 3 or a 4 unless you do what?
I don't know.
Make the Pythagorean.
You have to make a Pythagorean substitution. If you do not make a Pythagorean substitution, that means it's level 1 or level 2.
Coach, why do you know when the tornado is supposed to come?
There's no tornado.
There's a 4 out of 10 chance. There's a 6 out of 10.
40%.
Austin, did you have a question?
Oh, so I was saying, so it's number 8 level 4.
40% chance.
Number 8 is a level 3.
Level 3?
Yeah. 7 is the level 4.
Okay.
7's level 4.
7 is level 4.
What was it? Oh, no,
I think that was
I don't want to say anything on this one because
Alright. Number 7. Cosecant minus cotangent equals 1.
it don't.
First question I ask myself,
Like terms.
do I have like terms? The answer is
No.
no. So what do I do?
Move cotangent to the other side.
You guys are getting ahead of myself. You're getting ahead. I want a thought process. I want the same thought process every time.
Change it to whatever sign.
Eventually I do. You guys are all over the place.
No, that's right. No, you're supposed to square them.
We look at our terms, we
No.
see we have no like terms, so we're gonna move one to
If number two
the
doesn't work.
See, you guys are getting ahead of me.
Separate the triangle.
Because that's gonna cause you to mess it up.
What's in
You can't square it though.
I don't know.
Because a lot, if you're using that thought process, then on number 6 you would have squared both sides. And we
So
don't want to
change
square
it.
both sides.
No, I don't put it 1 over sine minus cosine over
No,
sine.
stop.
No.
I want it, yes, I want it all on one side.
Oh, I did that.
Now
I want you to do it all on one side. Because if you don't do all on one side, then what might you miss that you would have missed on number 6? What was I able to do on number 6?
Factor.
I was able to factor it out. You always need to get it on one side and try to factor before you do anything else. If you skip that step, then you're going to make a problem. Like a lot of people made number 6 much harder than it was because a lot of people squared number 6 when there was no reason to square number 6. So, even though you might be able to tell that you're going to have to separate and square, I want you to get it on the same side first. I want you to get it on the same side, and then I want you to eliminate that it is not possible to factor. So once I get it on the same side, I realize I cannot factor anything out, and I'm dealing with 2 trig functions, and neither one of them are squared. That tells me I need to do make my own Pythagorean. But I want you to get it on the same side and try to factor first.
We do that every time.
Every time.
Wait, what was that? What did you say?
If you do not have like terms, I want you to move everything to the same side and try to factor.
But
You always need to attempt factoring before you make a Pythagorean substitution and before you square both sides. Because if you miss the factoring one, that is going to screw the problem up. If you miss a factoring and you were supposed to factor, you're done. You got no prayer. Always check to see if you can factor first. Because if you skip the factoring one on the last one, you're dead in the water.
I'm already there.
All right. So I moved it over. I cannot factor anything out. There is nothing squared, so that tells me I need to separate and square. I'm going to recommend that we move both the cotangent and the 1 to the other side. Why would I recommend that?
Everything's positive.
So everything is positive. If you can get everything positive, get everything positive. Sometimes it's not possible. But if you can make it to where everything's positive, that reduces the opportunity for you to make a mistake. So now I square. And I don't know how many times I've said it, but I've said when you square a binomial, what are you going to get? A trinomial. People are still giving me binomials when you square a binomial. So I always like to square the first term. And square the last term, and then how do we get the middle term?
Square.
Multiply these two together times 2. So cotangent times 1 is cotangent times 2 gives me 2 cotangent. That's the easiest way to square a binomial. Now, once I do that, I need to make a Pythagorean substitution. Am I going to substitute for cosecant squared or cotangent squared?
We want to get cotangent, all cotangents.
Because I have multiple cotangents, that means the cosecant squared has to go. Okay, then it returns to just like number 3. Number 3, after you make the Pythagorean substitution, what have I asked you to do? Get it on one side, combine like terms. So, when I subtract cotangent squared over, that's going to cancel those 2 out. When I subtract the 1 over, that cancels the 1 out. So I'm only looking at 2 cotangent theta equals 0.
Oh my god.
Which means that cotangent equals 0. And again, anytime cotangent or tangent equals 0, I need to remember what cotangent is. Cotangent is cosine over sine, which means in order for cotangent to be 0, what has to be 0? Cosine does. Cosine is the x value, so I'm looking for x values that are 0. That happens at pi over 2, happens at 3 pi over 2.
Okay.
Since I made my own Pythagorean, that means 3 pi over 2 needs to go. Deal.
I see it like
Oh my
if
god.
we did 1 over sine minus cosine over sine. I see that it would work out the same except we have
You see dead
Did you
people?
say you see dead people?
How did you go from here to there?
sine tangent, so 1 minus tangent.
You're right. I did.
If you ever wanted to do something like that, it would be cosecant minus cotangent.
It's pretty good.
So it won't work that way.
I got it
I didn't.
So you left the one over there, you got that, you changed that, and that canceled. So you divided by
No
2,
hoods in
you got pi
the
over
classroom.
6.
Young lady.
Okay, so it's like, I'm not doing it.
Alright, so this one is considered a level 4 problem because we didn't have a squared trig function, we had to separate, we squared both sides. So that is a level 4 problem. That's the hardest type of problem when you're solving trig equations. Number 8. Alright, so what do I ask myself to begin with on number 8?
Like turn.
Do I have like terms? The answer is no. So what do?
Get it all on one side.
Get it all on one side. I want to move to the left side to keep my squared term positive. So we get tangent squared plus secant minus 1 equals 0. Once everything's on the same side, I want to try to do what? Factor. Can I factor?
No.
No. So then I do what? Pythagorean. So I've got to replace tangent squared. That turns into secant squared x minus 1. Plus secant x minus 1 equals 0. So I want you to do after that step.
Like turn.
Like terms, combine like terms. So that gives me secant squared x plus secant minus 2 equals 0. Then what? Two binomials. Factors of secant squared are secant and secant. Factors of 2 are 2 and 1. That tells me different signs. That tells me biggest one is positive. And we always do after we factor. Set them equal to 0. So this one's going to give me secant equals negative 2, which means I have cosine that equals negative 1/2. This one gives me secant equals 1, which means that cosine equals 1. So cosine and 1/2, that occurs at pi over 3. And it's negative, so what two quadrants is cosine negative in? 2 and 3. So 2 pi over 3 and 4 pi over 3. Cosine does not equal 1 at pi over 6, pi over 3, or pi over 4. So that means I need an x value that is 1. That occurs at 0. 2 pi over 3, 4 pi over 3, and 0.
I think I don't want your going back, and I just really easy ones on the front.
So that one would be a level 3 problem. So on that quiz, there were 2 level 1s, 3 level 2s, 2 level 3s, and 1 level 4 problem. No,
Yeah, can we
it
put
would
one
not
of those
affect,
sections?
it would not affect your grade that much, so you'll live. Alright, so next thing I want to make is kind of a workflow. To go along, I want to know a workflow, a thought process, what should you be doing? So, what is the very first thing we should be thinking?
Like turtles.
You should be asking yourself, do I have like terms? So we have a yes, we have a no. So we're going to go one of these two directions. So if the answer is yes, what do?
Combine
Combine.
them.
Combine.
Sorry.
Yeah, I'm sure. Like terms.
Thanks a lot to you.
If the answer is yes, then you combine and solve. If the answer is no,
Get it all in
all right, then what's the next question I ask myself once it's all on one side?
there.
Can I factor? Put the no over here. Oh no, we'll put the yes over there. I need more room for the yes or the no. So let's do the no or the yes first. If I can factor, then I factor and do what?
Set equals.
Factor and set it equal to 0. So if I can factor, then I factor and set it equal to 0. Okay, if it's a no, then I'm asking myself what?
Are all your trig functions the same?
Can you, or is this?
Can I make a Pythagorean substitution? Okay, can I make a Pythagorean substitution? So we'll put the no there. We'll put the yes there. All right, let's do the yes first. If it's yes, then what do? Substitute. Combine like terms.
In fact.
Factor. Substitute, combine, factor. If it's no,
Then you put it on separate sides.
separate,
It's there.
square,
And then
Set equal to
combine.
0.
substitute,
Oh,
Oh, and then you put it all on one side,
combine,
factor,
factor.
so you put it.
And that should be understood that after I factor, I'm set it equal to 0 and finish that up. So if you follow this in your mind, then you should be fine. So, do I have like terms? Yes. Combine and solve. Okay. Sometimes when I'm asking myself, do I have like terms? There may be only one term. So if there's only one term, then all I have to do is solve. That should be the easiest one. That's why most everybody got number 2 correct. Okay. If the answer is no, I get it all on one side. After I get it all on one side, I ask myself, can I factor? If it's yes, then I factor, set it equal to 0, and finish it up. If it's no, I ask myself, can I make Pythagorean substitution? Okay, if I can, then I substitute, I combine, and I factor. If I can't, then I need to separate, I need to square, I need to substitute, combine, and factor. That's the thought process. You follow that thought process, you can do any problem that I give you.